Okay guys, here's the direct comparison test. This says let's have two continuous functions on some interval from a to infinity. So like from 1 to infinity, from -7 to infinity, it doesn't matter what's happening on the left side, as long as at some point we're continuous. All right, and two things are important. First off, both functions are positive. The other is that f of x is less than or equal to g of x on this whole interval. Again, before this doesn't matter, but from some point on until infinity, g of x is the bigger function. Then the direct comparison tells us that if the larger function converges, then the smaller one converges. And it tells us if the smaller one diverges, then the larger one diverges. So let's just look at what this means. Okay? Here's some function, f of x. All right? Here's some function, g of x. Okay, and we'll pick our a to be right here, where from this point on, g of x is always the larger function. Well, what are integrals? Integrals are areas. So if this area under here is finite, that's what converges means, it's finite. Well, this area is less than it, so this area has to be finite as well. Similarly, if we look at the second part, again, an integral is just an area. If this area is infinite, well, this area is bigger, so this area has to be infinite as well. So that is the direct comparison test. So how does this help us? Sometimes we have something and we want to investigate the convergence of it. Okay, this is a really horrible eraser. We want to investigate the convergence of it, but we don't know how to integrate it. And this is where the direct comparison test comes in handy. So just for example, suppose I take the function from 1 to infinity of 2 plus the sine of t over t squared dt. And I'm trying to figure out if this is infinite or if this is finite. Well, the sine function is always between -1 and 1, right? So I know that my numerator here, right, is always less than or equal to 3, right? Because the biggest sine t can be. B is 1. So I know that this integral is less than or equal to the integral from 1 to infinity of 3 over t squared dt. Now, you guys studied the p integrals, so we should recognize this as a convergent integral. But if not, we can go ahead and integrate it, right? This is equal to the integral from 1 to b, 3t to the minus 2 dt, limit as b approaches infinity. And so if I integrate that, I get the limit as b approaches infinity, right, of -3t to the minus 1, so -3 over t from 1 to b. Well, what's that equal to? That's equal to the limit as b approaches infinity of -3 over b minus a -3 over 1. Well, as b approaches infinity, this approaches 0. So this limit is equal to 3, which is finite, so this converges. So what does that tell us? That tells us that the integral from 1 to infinity of 2 plus sine t over t squared dt also converges. Now the question is, how do I figure out what to compare it with? Whenever possible, we want to try to compare with the p integrals because they're the easiest ones to look at and know, yes, they converge or yes, they diverge.